So now we finally come to the part of the course and the part of this unit where we talk about intervals of convergence at the very beginning. And if you didn't watch the videos from the beginning of chapter 11, 11.1, 11.2, go back and take a look at those. We talked a little bit about intervals of convergence graphically. I had graphed it. We had looked at these different parts of the graph and said, yep, the two functions are about the same on this interval, but then outside that interval, they become very different from each other. And we sort of eyeballed what the intervals were, and we said we'll eventually worry about the endpoints. Well, before this next series of videos are done, we will have worried about the endpoints. So let's start by looking at the ratio test. Remember that we looked at the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. So we had looked at the term over the term before it, and we found out that it equaled something. And there were three possible values that we could have. If that limit was greater than 1, we said the series diverged. If we said that limit was equal to 1, the test was inconclusive. But if that limit was less than 1, right? It's got to be positive, greater than less than 1, it converges. What we're going to do is we're going to work in the other direction. Now we're going to say, I'm taking this ratio, I'm forcing it to be less than 1. You tell me for what values of x that's true. Whatever the answer is, that will be the interval of convergence. So again, before we had said, here's our two terms, we divided them, we came up with a limit. Does it converge? Now I'm going to turn things around backwards and say, it does converge. You tell me what values of x this thing converges on. So let's take a look at an example that we already know the answer to. Let's say I looked at 1 over 1 plus x squared. Okay, 1 over 1 plus x squared is 1 over 1 plus x, except that the signs alternate and the x's are replaced by x squared. So we end up with a 1 minus x squared plus x to the 4th minus x to the 6th and so forth. So as a series, this becomes what? It's an alternating series. It's a negative 1 to the n, x to the 2n, starting where? In this case, it's got to start at n equals 0 up to infinity, because I'll get x to the 0, x to the 2nd, x to the 4th, and so forth. All right, so the first step I would do if I wanted to find my interval of convergence, right? So that's my question, find the interval of convergence. Step 1 is the ratio test. So I'm going to take the n plus first term and divide it by the nth term. So I'm going to take negative 1 to the n plus 1, x to the 2, replace the n with an n plus 1, and then I'm going to divide it by negative 1 to the n, x to the 2n. Okay, and I want this to be less than 1 as the limit approaches infinity. All right, next step, simplify. Inside of my absolute value brackets, I can separate these into two pieces. I've got negative 1 to the n plus 1 over negative 1 to the n. And here I've got x to the 2n plus 2 over x to the 2n. And again, I want that to be less than 1. Well, what happens in this first set of terms here is that I just get negative 1. But then when I take the absolute value of negative 1, it turns out that whole piece is irrelevant anyway. All right? So really what I'm looking at is a limit as n approaches infinity of this second piece. Well, over here, the two n's will cancel, and I'll just end up with x squared. All right. Those absolute value brackets are a little redundant because the absolute value of x squared is just x squared. So, and the other thing that is kind of funny is now we don't have any more n's, right? We had x to the 2n plus 2 over x to the 2n, so there were two more x's up on the top, and the n's went away. So really what I'm left with is x squared is less than 1, which means that x is between negative 1 and 1. That's my interval of convergence. We'll worry later about the endpoints, but I'm going to label this right now as my interval of convergence, and I'm not going to include any of the two endpoints. This is not shocking, right? If 1 over 1 minus x converges between negative 1 and 1, then that also means that 1 over 1 plus x converges between negative 1 and 1, and this one also converges as well. So that's the interval of convergence. We have another term that might be helpful, and that is the radius of convergence. Right, what do you remember about circles? In a circle, the diameter goes from end to end. Right? The radius goes from a center to a point on the outside. Same thing here, right? The interval of convergence has a length of 2. The radius of convergence then is half the length of the interval of convergence, which is 1. So the radius of convergence goes from the center of the series to the outside of that interval of convergence. So in this case, it goes from 0 to 1. My radius of convergence is 1. All right, let's take a look at a few examples that involve radius of convergence. All right, some of them will be more simple than others. We should get a taste of all different kinds. So again, here's my question. I want to find the interval of convergence. And here's my series. The sum from n equals 0 to infinity of x to the n over n plus 1 times 2 to the n. Well, that looks interesting. First thing is, let's set up the ratio test. Remember that this is the reverse and that this time I'm going to say that I want that limit to be less than 1. You tell me the values of x's that will make that work. This is going to look a little funny. Let's do our best to fit this on the screen. Limit as n approaches infinity. Absolute value of the n plus first term, which is x to the n plus 1. Down the bottom, n plus 1 is n plus 2. And then that n plus 1 next to the 2 comes from the 2 to the n. So it was 2 to the n, now it's 2 to the n plus 1. Now, I could write this over the next term, but isn't that the same thing as multiplying by the reciprocal? So I'm going to do n plus 1, 2 to the n over x to the n. And I want this to be less than 1. Now, that looks awful. Here, let's separate these things so that they're organized a little bit better. So the first thing I'm going to do is I'm going to put my n plus 1 up here and an n plus 2 down there. I'm going to put my 2 to the n up here and a 2 to the n plus 1 down there. And then I'm going to put an x to the n plus 1 over here and an x to the n over there. All right. Make sure that I've included everything accurately. I got the n plus 1 and the n plus 2. I've got the x's in the right spot, and I got the 2's in the right spot. All right. Beautiful. Let's evaluate this. Term by term. So the limit as n approaches infinity of this first piece here, isn't the numerator and denominator almost exactly the same number? Sure, if you put a 0 in for n or if you put a 1 in for n, you're going to get different numbers top and bottom. But let's say you put in 7 trillion for n. Essentially, you've got the same thing top and bottom. If you don't believe it, L'Hopital it once, you'll get 1. All right, look at the next one. You got a 2 to the n on the top, a 2 to the n plus 1 on the bottom. So you've got one more 2 on the bottom than you do on the top. So if you start canceling out n 2's from the top and the bottom, you'll have a 1 left on top and a 2 left on the bottom. Same idea over here. You can separate that x to the n plus 1 as x to the n times x to the first, right? If you added those two green things back together, you get x to the n plus 1. So that one and that one cancel, and you're left with just an x. Oh, well, that's not so bad anymore. Okay, what does it give you? It gives you the absolute value of 1/2 x is less than 1. Great. So now get rid of that absolute value, and you end up squeezing it between -1 and +1, right? If the absolute value is less than 1, it means the values could range from -1 to +1. Right, multiply everything through by 2 so that we get rid of that 1/2, and we end up with -2 is less than x is less than +2. All right, so what can we conclude? We can conclude that the interval of convergence goes between -2 and 2. And the other thing we can conclude is that the radius of convergence is 2. Because if the center of the series is 0, is 2 units from a center to a point on the outside, that's the radius of convergence. All right, good. Let's take a look at a couple other cases. So we've had an interval from -1 to 1. We've had an interval from -2 to 2. Maybe I can come up with a more interesting one. We can hope. All right, let's take a look at this one. Suppose I've got the series that goes 1 plus x squared plus x to the third plus x to the n. And I'm going to divide by 2 factorial, by 3 factorial, by n factorial. Okay, I think I made something. What have I made? Do you recognize this as the series for e to the x? And it's centered at 0, right? So it means it's a Maclaurin series, centered at 0. My question is, what's the interval of convergence? How often does this e to the x series match up with e to the x itself? So what's the formula? X to the n over n factorial, so I'll set up my ratio test. I'll take the n plus first term, so I'll do the limit as n approaches infinity. Take the n plus first term and divide it by the nth term. So instead of dividing by the nth term, I'm going to multiply by the reciprocal of the original one. So the original one is n factorial over x to the n. And this I want to be less than 1. All right, so let's use the same idea that I did before. I'm going to put the n's over here. I'm going to put the x's over here. And this way it's easier to simplify, I think. All right, take a look at that first set of terms, the n factorial over n plus 1 factorial. N factorial means n times everything before it. N plus 1 factorial means n plus 1 times n times everything before it. That's how I get rid of the n factorial. So this thing here is really 1 over n plus 1. Now take a look at these terms. You've got n plus 1 of them on the top, n of them on the bottom. So they all cancel except for one of those x's. Which now leaves me with sort of an odd situation. I've got the limit as n approaches infinity of 1 over n plus 1 times the absolute value of x being less than 1. Well, if you evaluate this first piece here, the limit as n approaches infinity of this is going to be 0, right? As the x's or the n's on the bottom get bigger and bigger, that whole thing is going to 0. So I end up with 0 times the absolute value of x is less than 1. For what values of x will that be true? That will work for all values of x. All right, so where is that ratio less than 1? It's less than 1 everywhere. And so what is our conclusion? Our conclusion is that it converges everywhere. It converges on the interval from negative infinity to infinity. Remember when we looked at series originally, we said there were 3 options. The series could converge on a finite interval, which is the first couple of examples we did that were like -1 to 1 or -2 to 2. We said it could converge for all x, and so here it is. It converges for all x. There is a third option too, right? That upside down a means for all. So you could say it converges for all x. It converges for the interval from negative infinity to infinity. Those are both possibilities. All right. Let's take a look at another one. Suppose I looked at this function. So I'm going to look at the interval of convergence for the sum from n equals 1 to infinity of n plus 1 factorial times x to the n. So I would like to know on what interval this series converges. All right, so I might run the ratio test, take the limit as n approaches infinity of, now replacing that n with an n plus 1 gives me an n plus 1 plus 1, which is n plus 2, x to the n plus 1. And on the bottom, I'll have n plus 1 factorial x to the n. So it's not a crazy fraction like I had before. I want to know, when is that going to be less than 1? All right. Let's look at these funky factorials. N plus 2 factorial means n plus 2 times n plus 1 times everything before it. On the bottom, I have an n plus 1 times everything before it. This will cancel out all the n plus 1 times n minus 1 times n minus 2s, etc., and I'm left with just that n plus 2. Right, over here, I'm left with an x, because I've got one more x on the top than I do on the bottom. Well, this leads me to my next line, which is that the limit as n approaches infinity of n plus 2 times the absolute value of x has to be less than 1. Now, as n approaches infinity, that thing approaches infinity too. So the only time that I'm guaranteed that this thing is going to be less than 1 is when x is equal to 0. Right? So when x is equal to 0, then that limit has to be less than 1. Outside of that, I have no guarantee that that thing is less than 1. So in this case, we say it converges only at its center. This thing converges only at x equals 0, which is its center. And therefore, the radius of convergence is 0. The series will converge only at one point. At all the other points, it will be very different from the function itself. Right? So it is possible to have an interval of convergence at 0, and that's what it looks like. All right, so I guess our next thing to look at is how do the endpoints converge, and we'll do that in the next video.